a software engineer, primarily digital TV at the minute, but I've done some other stuff in industrial automation as well. I'm a hobbyist maker. I do a lot of electronics, reverse engineering stuff at the minute. Not going to bore you with the rest of that. You can look on the slides later. And I promise you I'm not a James Bond villain in disguise if you missed him at the front there. Just so you can check. So this is a talk entirely about analog TV. There is no digital MPEG DVB stuff in here. So please just relax and watch the TV. So the whole point of this talk is I got hold of some kit from a cable TV system that was in operation in the United States. Some of the equipment came from elsewhere. And I have basically been putting this together in my front room. But rather than just show that off, I've been piecing some little bits together off Amazon, eBay, and so forth. And I figured I'd show off how you can actually do this in your front room too. So, quick introduction to cable TV if you're not aware of its history. It started out as cable-based radio and TV relay services. So they would put an antenna on a big hill with line of sight to the transmitter, run cables down into the valley that couldn't pick up the signal, so obviously hill, valley, hill blocks signal, and amplified the signal, retransmitted it over the cable into people's houses. People paid a little bit towards the upkeep of the system, but this had a little bit of a side effect on the cost of entry for new channels. So, for instance, you could have a local channel, and previously to run a local channel you're talking about radio spectrum licensing costs, you're talking about the cost of a massive, potentially multi-kilowatt transmitter, antennas, planning permission, all this stuff, putting the cost up into a significant number of digits of pounds. And now, because you've got this cable network set up, all you really need to do to add a new channel to it is buy a $2,000 modulator, put it in the equipment rack at the head end, and run the video signal to it. So this led to a massive surge in, sort of an explosion in channels. So you had HBO turning up. This was in the US. And similar things were happening over here. There were local cable networks were creating their own local channels with like local news, you know, the Village Fit and so forth, just streamed, well, on the TV. You could tune in and watch it. So a typical commercial setup involves a central office called the head end, where you would have your receiving antennas, your satellite dishes and all the receiving equipment. That generates a signal that is then amplified and goes down what's called the trunk cable, which is a very high diameter, low loss coax cable. That runs down to a street cabinet where there are devices called taps, which are just low power signal splitters. They're passive devices. They take a small fraction of the signal off, about 20 dB, and then pass the rest along to the next line, the next box in line. So this, there may even be amplifiers in these street cabinets, powered from obviously 240 volts, the same as street lights, for example. But this left the cable companies with a route to improve. There was some sort of weaknesses with these, in that after a while the signal would get quite poor because of all the amplification steps, adding noise, the signal getting weaker and so on. So they moved in the 1980s to running fibre optic cable from the head end to one or more of the street cabinets, putting a fibre optic receiver in there, and then that launched what was effectively a fresh signal straight out onto the cable. And then that's split off for the various subscribers. and then later on we got sort of the first cable modems. But this is all rather complicated and a little bit too much to put on your kitchen table. Thankfully, you can do it a little bit easier. The basics of it is you need a video source that can be either composite or HDMI. You need a video modulator which takes that video source and converts it to an AM modulated signal with the sound on an FM carrier nearby, and then boosts it up in frequency to somewhere in the couple of 100 megahertz range for a TV or a cable box to receive. The cables are fairly standard. If you've done a satellite TV installation, it's a Type F connector. It's the same as is used on satellite dishes up and down the country. The parts to get started with that are cheap. And then after that, you just need a TV with an analog tuner. If your TV is fairly old, you've probably got one. If not, there are other ways. If you haven't got an analog input on your TV, get an old video recorder. As long as it turns on, set the channel frequencies up, and it'll work as a passable TV tuner. Equally, TV tuner card for your PC might be an option, or you can buy a cable box like that one and get that working, but you have to kind of pray that it hasn't been set to time out and shut itself down, otherwise it'll be just stuck on one channel. If they don't see the head end in a while, they just shut down. The nerdy way is to make your own. You can just buy this little tin can that takes 5 volts in, and the RF signal goes in, I2C to tell it which frequency to tune, out comes video. So you can build your own cable box. Video sources, fairly obvious. Raspberry Pi is a good one. For the HDMI output, you can also use the PCs, if you've got a spare PC lying around. And then that all hooks up to the modulator. So what you've got there is a fairly standard £30 Chinese TV modulator. The only difference between that and the rack mount ones is the output quality is not quite as nice, and the signal is twice as wide because it's missing a filter that's quite an expensive part. So you just have to remember to skip a channel. So you go from channel 35 to 37 to 39 and so forth, just to avoid interfering with the next one down. And all you need to do is your antenna goes in one side, RF output comes out of the other. If you've got several of these, you can link them in a line with a few different video sources. And when you do it, you get that. And on the left there is the output signal as seen by my spectrum analyzer. It's just a normal analog TV signal, not a particularly clean one. I think that actually came from an SDR that I was debugging. And the end result is you have, I think that's The Greatest Showman, on your TV in your living room, generated completely locally. And obviously you can expand this, as I hinted earlier. That is a channel selective level meter. So what you need to do if you start expanding the system is keep an eye on the signal strength of each channel, make sure they're all about right. There's guides online, about 75 dB microvolts, which it'll just display on the display there. If you're going into a TV, or a little bit stronger, 5 to 10 dB millivolts if you're going into a cable box. So that's pretty cool. We've got our favourite movies, shows on the TV. Where do we go now? So we can stick a teletext signal on there. We're using a Raspberry Pi to generate the video. There's fairly open software. You just download this, install it, set it up. There's even a demonstration CFAX type service called TFAX that you can download using Subversion and just run SVN update, and it keeps up to date. You can generate your own pages fairly easy with the teletext editors. So there's a couple on there, I think. ZXNet, yeah. So they work pretty well. The other thing you can do is, if you're not using a Raspberry Pi to generate the video, if you can get your hands on a device called a teletext data bridge, that will effectively copy the teletext signal from one video signal to another. So they're pretty handy if you get into teletext, but they're not essential. They turn up on eBay occasionally. We could create a electronic program guide. So these boxes, these cable boxes in the sort of 80s and 90s were really just very smart TV tuners with a little bit of smarts to basically shut down or put you on a channel that just says, hey, you haven't paid your bill, if you didn't pay your bill. Other than that, they're just TV tuners. They didn't have any data reception capabilities, so they couldn't display any program guides. The later ones had a channel list, but it was quite primitive. It's really no more advanced than what was on the TVs at the time. Maybe you want to put a weather channel on there. Advantage here is you just turn your TV on the morning, and you can even have these cycling through, so it's weather for 10 seconds, local news, so on. Put a nice bit of music in the background, and you have something that is a little bit of background music while you work, and a little bit of sort of information up on a little screen to one side of your computer monitor, for instance. One of the things I've been working on that's a little bit down the garden path, this is an old Canadian cable TV application that's a little bit interesting. It's kind of halfway between cable TV and a cable modem, and it's called the Nabu PC. So what you have is that box on the top, I think, is the cable adapter, and that takes the cable TV signal and captures programs that are sent down the cable and sends them to that little PC on the bottom, which is a slightly modified MSX, so it's a Z80 processor. And you could play games on these, and the idea was you pay a little bit every month as a subscription to this service. There's about 1,000 of them were found in a warehouse in America last year. There was a bit of people were in the retro computing community were going a little bit wild about them. So there's quite a big community has grown up around them now. So I hinted about old cable boxes and reusing them, and they turn themselves off if they haven't seen the data stream from the headend in a while. So what if we wanted to bring one of those back online? Well, we need to generate that data signal. And that really just contains the date and time, a command to reset that timeout timer to say, this is active. There's an identification signal on there called the site code, or sometimes called the network password, which the box will compare against what it's been programmed to look for. And that's the basics of getting it working if you're just using the default frequencies. So this is the piece of kit that I found, or I picked up. So a couple of years ago, someone found the manuals for a lot of General Instrument cable TV equipment, so the equipment that's actually at the head end. And there was a system called Sega Channel, where it was similar to the Nabu PC, but for Mega Drive games. And someone found these manuals for the Sega Channel head-end system, which also included the cable network controller, the addressable controller. So this is basically a PC. with some extra fancy bits. It's got a lot of serial ports. The standard configuration was 8 serial ports. It had a tape drive for doing backups, but the interesting part of it is it's got a second PC inside of it, which is this little thing. So that is called an ANIC, Asynchronous Network Interface Controller. There's a data in and out port that has biphase encoded RS-232 data with some command packets flying around on it. Interestingly enough, aside from the power, it also has SCSI. It actually works backwards to how you might think. If you're thinking this works like a disk drive, no. It actually works as the initiator on the SCSI bus. The PC is the target, and the ANIC basically sends a message to the PC whenever its buffer is empty, asking, you know, the 486 that's running the headend software, can you give me the next packet to send, please? But it's a little smarter. It can do some protocol offloading. So you've got lists, which are just packets that are sent to several different cable boxes that are all the same. And it will just sit and send those in the background while it's not doing anything more that's more important. A punch is a command that's just immediately sent and any response captured, and it's sent straight back to the head end. And then a pull is a punch with some return data. So I showed you the ANIC. It's an embedded 286 PC with a megabyte of RAM and a Xilinx FPGA. So it's a pretty ridiculous bit of hardware for the time. It would have been extremely expensive, and unfortunately, it was also broken. So that error message ain't great, but it says initialization error, no ANIC cards detected, not enough for present system configuration, and basically that bit says everything has stopped working. Oops. So that wasn't great. This was all put into this is only a K62 PC I had lying around, off-the-shelf kind of graphics card. Did some upgrades later on, and the actual fault on the ANIC was the battery for the CMOS RAM had leaked, which is actually on the lower board that hosts the processor, and it had leaked underneath a chip, and it took a lot of digging to find that, but once I did, it was 4 pieces of wire and it worked again. But the signal that comes out of that needs to go into a box called a data commander, or would normally go into that on the head end. That generates a FM modulated or FSK modulated, if you prefer, version of the incoming data, and that's what the cable boxes listen for. But you can't find them, or I haven't been able to find one in 2.5 years. But it's just FM modulated. It can't be that hard. Yeah, off-the-shelf spectrum, sorry, not spectrum analyzer, sorry, RF signal generator. Pipe the data signal into the modulation input, set the frequency, set the modulation parameters. That's the head-end software. Running on the left there, so you've got all these log windows. Wirelink is the billing system interface. The logger window up at the top is the main software startup. There's a graphical version of the UI that you can just see on the right there. And above my head here is my amber screen text dumb terminal displaying one of the serial port user interfaces, and some of the data that was left on the system from its previous owner. So it's got channels set up on it, it's got HPO, it's got various things. And you can just go in there and set up a box, give it the serial number, it'll assign it an address on the system, you tell it what subscription package this box is supposed to have, and it runs away and the box works. So the next steps for me, the boxes can actually do a return path where they have a modem inside them and they transmit data back to the head end. So that just needs a receiver, and I'm planning to put one of those together. And that's the weird thing about it is it's actually 300 kilohertz wide FM, like a broadcast FM signal, like the downlink, but it's down at 8 to 10 megahertz, which is quite low, and there just doesn't seem to be any commercially available equipment to receive that. So that's a problem to solve, but hopefully not a big one. Then just reverse engineer the head end and pop it on a Raspberry Pi to get rid of this big 486. And there's a little group of us we've set up a little Discord server, and we've got together, figure out what equipment we've all got, and hopefully build, a couple of these more modern head ends across the world and do some demos. There's also broadcast equipment floating around on the used market. Character generators are a fun one. If you've seen the little banners along the bottom of the screen on BBC News, for instance, they're generated, I think the BBC use Aston character generators, but it's a box that sits in line between the camera feed and the actual transmitter, and just its job in life is to take text data from the computers in the production suite and put that all together, overlay it onto graphics, and you get something like this, which is one of the demos that comes with it. So it's all I'm sending to the card is this is all text commands. It's got the graphics and animations cached. It's got the fonts cached. And you can generate all this with just a text file, basically. And this is a PCI card that will go into any Windows XP PC. So it won't work on anything more recent. It's got 64 megs of RAM. There's drivers for it and there's software, but unfortunately the software checks that you have one of the cards that came with that software. So you can't use it directly with that, but you can use it to edit graphics and things for the graphics templates for the card. Come on. Next slide. One thing that I've recently got is a matrix switch. So these are handy if you're putting a system like this together with multiple channels. Main thing they're useful for is being able to reroute signals. That's all they do, really. But what you can do with them is, if you've got something like a Chiron, which is the graphics generator I just demonstrated, you might want to use that on different channels. So maybe one night you want it on the first channel, next night you want it on channel 3. Same use case as in a television broadcaster. You don't want to dedicate one to a single channel. And what the matrix switch allows you to do is do all of that with computer commands, RS-232 commands, switch the ports around, and just reroute the signals without having to recable everything. So yeah, that's all the stuff I've put together so far. I'm planning to take the head end that I've got, spend a little bit of time sitting down and reverse engineering the commands that it sends. So there are some test applications on the hard drive of that machine that you literally run them, and it says, here are all the valid commands for this type of cable box. And it guides you through sending them, and then you get a little data burst coming out of the data card, out of the ANIC. So I've got a little Arduino hooked up to it that can decode the commands and log them to a text file for me, and then it's just a matter of changing the parameters going into those commands in that test tool and writing down what happens and writing a program that can also generate them. Like I said earlier, I'm planning to do an all-in-one box with the modulator and the receiver. In truth, I'm probably going to gut I've got a little FM radio on my desk at home. I'm probably going to try just chopping that apart and seeing if I can tune it down to 8 megahertz. If it won't, I've got a broken cable box, and like I said, the signal is the same up and down. You can take a transmitter and a receiver, change the frequency, and they'll work together. So I might take that path. But I also have a video scrambler, and this is a thing that I've been working on recently. There's a tool called Hack TV which can generate video signals using a SDR radio. So I'm working on adding the video scrambling to that, and that will just, if someone picks up one of these cable boxes, you can generate both the FM downlink with the SDR and then generate the video signal. But obviously, it's if you've only got a single channel SDR, you can only generate one at a time. But that would make it very easy for people to get involved in this. This is sort of inspired by Marold's work with QTEL. We've now got a copper telephone network on site at EMF. I wonder if we could have a cable TV network too. That would be quite nice, I think. Anyway, that's it for that. If you have any questions, I'm going to hang around probably outside the Robot Arms and get myself a drink. Feel free to wander up, ask me questions about this. Otherwise, my website is up at the top there, and my contact details are on there too. And it's been a pleasure. Thank you very much.